Let's talk about managing torque in flight. In a hover, torque control is critical because the helicopter isn't moving forward, so the tail rotor must consistently balance the torque. Pilots continually make small adjustments to the pedals to maintain the desired heading. In climbing and descending, as the engine power increases during a climb, the torque from the main rotor also increases. The pilot must increase the tail rotor thrust accordingly. During the descent or when reducing power, the pilot reduces tail rotor thrust. In an autorotative descent, when the engine is not driving the main rotor system, the torque is minimal and less tail rotor is required. The pilot may need to adjust the pedals to maintain control, but the balance between the rotor torque and the tail rotor thrust is different compared to powered flight. Performing a pedal turn involves adjusting the tail rotor thrust to rotate the helicopter around its vertical axis. In both cases, the main rotor torque and the tail rotor thrust must be balanced to avoid over-rotation and uncontrolled spin. Crosswinds can affect the efficiencies of the tail rotor, sometimes making it harder to control torque, especially in strong or gusty conditions. Pilots must be aware of wind direction and adjust their pedal inputs accordingly to maintain control. In certain conditions, such as high crosswinds or during maneuvers, LTE is a factor. Controlling the torque is fundamental to helicopter flight and involves balancing the rotational force generated by the main rotor with counteracting thrust from the tail rotor. Hey, if you enjoyed this video and you want to learn more, I've got a free course to get you started with helicopters. Check out the link in the description.